x. Let's integrate. Now you know that to integrate, you need to take the constant terms outside the integral sign. So I'll take minus 5 over 6 out. So I have minus 5 over 6. Then I'll be left with integral of the x is down, so 1 is on top holding it. So we have 1 over x plus, this one is okay, integral of 1 over x squared plus, this 2 will come out. So look at it here, 2, then integral. So 1 now is on top holding the x minus 1 down. Okay, minus 4 over 3 will come out. So you have 4 over 3 integral of, so 1 now is on top holding the x plus 2. Okay, all of them, don't forget with respect to x, so the x. Now let's integrate. So this is minus 5 over 6. The integral of 1 over x, of course, we now know how to integrate rational function. So what do? We say go to the denominator. If you differentiate the denominator and it gives you what you have at the numerator, you take the ln of the denominator. So now if you differentiate x, you will get 1. That means take the ln of the denominator, x, plus, if I differentiate the denominator, I will have 2x, which is not the same thing as this. But this integral of 1 over x squared can be written as integral of x raised to the power minus 2. Of course, 1 over x squared is the same thing as x raised to the power minus 2. So how do we integrate? Don't forget, you add 1 to the power, so that will be x raised to the power minus 2 plus 1 all over divided by the new power, which is minus 2 plus 1. So that is x raised to the power minus 2 plus 1 is minus 1 all over minus 2 plus 1 is minus 1. So this minus, look at it. Now, anything divided by 1 is that same thing. Okay, so this is minus. Then you write this in fraction form. This small minus is 1 over, then x raised to the power 1, you bring it down, which is 1 over x. So that is the integral of this. So having integrated this, the answer is minus 1 over x. We're done with that. Plus 2. Now let's differentiate the denominator. The derivative of x is 1 and the derivative of 1 is 0. So if you differentiate the denominator, you get the numerator. So that means take the ln of the denominator, x minus 1. Okay, minus 4 over 3. Differentiate the denominator. That is, if you differentiate x, you get 1. Differentiate is 0. So the derivative of x plus 2 will give you 1. So which means take the ln of the denominator. So we are done integrating. At the end of integrating, you must put there plus c. This is exactly how to integrate this particular integrand by partial fraction. So this becomes the outcome of the solution. Except you want to apply some laws of logarithm, raise this to power this, raise this, but this actually can be your final answer. So that is the solution to this particular integral. Find the area of the region bounded by the curve y is equals to x cubed over 3, the x-axis and the lines x is equals to 0 and x equals. So these are the boundary from 0 to 4. So it's very simple. We know that the area A is equals to integral from A to B of y dx. Now, you are told that A is given to be 0 and B is given to be 4. Okay, that means that y is equal to, of course, y is in the question, x cubed over 3. So pack everything, put into the formula that the area A is equal to integral from 0 to 4 of y, which is x cubed over 3 dx. So we can integrate from here. And note that before you integrate, you just take the constant outside the integral sign. So that will be 1 over 3. This is 1 over 3. Integral of 0 to 4 of x cubed dx. Meaning you have to integrate this with respect to x. So how do you integrate? Add 1 to the power. Divide it by the new power. So that will be x. This is 1 over 3. Look at it. 1 over 3 into the integral of x raised to power 3 is x raised to power 4 all over 4. 0 to 4. In other words, add 1 to this power divided by that new power, which is 4. Okay, now substitute the upper boundary. So that will be 1 over 3 into 4. Put this 4 here over 4 all over 4 minus, put the lower boundary, that is 0 raised to power 4 all over 4. So that means 1 over 3 into 4 raised to power 4 that is 4 times 4 times 4 times 4, which is 256 all over 4. Of course, 0 raised to power 4 is 0. 0 divided by 4 is 0. So everything there is gone. Now, 4 cancels itself. 4 goes into 256, 64. So 1 times 64 is 64 all over 3 square. So it is square units. That becomes the final answer to this particular question. Okay, so this is the second question in the manual. It says, find the area of the region bounded by the curves y is equals to cos x and y is equals to sin x. So there are two curves there. And the region is between 0 to pi over 2. So let's start by saying that the curves are y equals to cos x and y is equals to sin x. So we are still, there are two functions there, two curves there. So which one will come first? It is the one that is greater that comes first. How do we know which one comes first or which one is greater? If you take the cos of 0 and if you take the sine of 0, which one is greater? Let's find the cos of 0. Cos 0 is equals to, if you want to remember sine 0 and cos 0, all those things, you can use the sine graph and the cosine graph. For instance, the sine graph ranges from 0, 1, 0 to -1. And the sine graph starts from the origin. Whereas the cosine graph is 1, 0 and -1. It starts from 1. That's a cosine graph. So this means that sine 0 is 0 because it starts from the origin. But sine 90 is from here to here is 180. So the middle here is 90, which corresponds to 1. So sine 90 is 1. Whereas cos 0 is, it starts from 1. Cos 0 is 1. And cos 90 is, this is 90. So it bounces to 0, is 0. So you see that cos 0 is 1 and sine 0 is 0. So cos 0 is bigger. So that means our cos is bigger than, sine 0. This one is 1, this one is 0. So that means our cos will come first and sine will come second. Okay, so if we do that, we are going to have integral from 0 to pi over 2 of cos x minus sine x dx. So this is what we are actually going to integrate. All right. It's important to know that the integral of cos x is sine x minus, when you integrate sine x, you must have minus cos x. You can find that out. Okay? 0 to pi over 2. Now, this is sine x minus minus is plus. Plus what? Cos x, 0 to pi over 2. So we are going to substitute the value of the, because this is 180 divided by 2 is 90. So this is bigger, is on top, and this is small. Okay, now let's substitute the values into the upper limit. So that will be sine pi over 2, sine pi over 2 plus cos pi over 2 minus, that's how you substitute, minus, then put the lower limit, which is sine 0 plus cos 0. Okay, now pi over 2 means that will be sine pi over 2 is 90 plus cos 90 minus sine 0 plus cos 0. Okay, so sine 90, now remember that sine 1, sine 0 is 0, so sine 90 is 1. This is 1 plus cos 90 is 0 minus sine 0 is 0, sorry, and then cos 0 is 1. So 1 plus 0 is 1 minus 1. That is 0 plus 1, which is 1. 1 minus 1 is 0. So the area is equals to 0 square units. So that is the value for the second question. Now we take a look at the third and of course the last question. Find the volume of the solid obtained by resolving the region outside the curve y equals to x squared and between the lines y is equals to 2x minus 1 and y equals to x plus 2. So we are going to, there's no boundary in this question, but we are going to use the equation of the lines and of course the equation of the curve to obtain the boundaries. So let's pick the equation of the line, that y is equals to 2x minus 1 and y is equals to x plus 2. Now, if y is equals to 2x minus 1 and y is equals to x plus 2, this equation 1, this equation 2, y is equals to y, meaning that 2x minus 1 is also equals to x plus 2. So that means we can equate these two equations to have 2x minus 1 equals to x plus 2. From here we collect like terms, so 2x minus x, okay, equals to 2, minus 1 will cross and become plus 1. 2x minus x is x, equals to 2 plus 1 is 3, so that's the value of x. Now, put this in any of the equation, you will definitely get the same answer, because if you put 3 here, 2 times 3 is 6, 6 minus 1 is 5, but if you put 3 here, 3 plus 2 is still 5. So that means that I can say that y is equals to 2 times 3 is 6, 6 minus 1 is 5. Okay. Now, at x equals to 3, I can get my value of y from the curve. So I can say that y is equals to, I put 3 here, 3 squared, which is 9. And at y equals to 5, I can find my value of x from here. So put here 5 is equals to x squared. When this square crosses, it becomes square root of 5 is equals to x. So that means that at x equals to 3, y equals to 9, and at x equals to root 5, y equals to 5. At x is equals to y is equals to 5. So we have gotten the boundaries, but then we need to know that the formula for finding the volume of a solid could be given by V, which is the volume, is equals to integral from, let's say that this is x to x, or we can use a to b, where at this point a and b are just, we could use the values of x, since from the formula what we have is 2 pi xy dx. So from this formula we can observe that v will be equals to, integral from a to b of 2 pi x into, what is y? Y is equals to x squared. So this is, in the place of y, you put x squared, okay, dx. So that means that v is equals to integral. So pick the constant term. This is 2 pi outside the integral sign. Then you'll be left with x times x squared, which is x cubed dx. So I'm dealing with the x function. That means I'm going to use these boundaries of x, which is the lowest is root 5. 3 is bigger than root 5. So root 5 will be down and root 3 will be, 3 will be up. So this is what we have to now integrate. So it therefore means that the volume V is equals to 2 pi, okay, integral of x cubed is x raised to the power of 4 all over 4. Then you put root 5 and 3. So we are going to substitute the value of the upper boundary first, which is 2 pi. In the place of x, you put 3 into 3 raised to the power of, put 3 here, that is raised to the power of 4 all over 4. Then minus, you put the value of the lower boundary, which is 2 pi into, in the place of x, you put root 5 raised to the power of 4 all over 4. So from here, we can see that this is 2 pi, 3 raised to power 4 is, that's 3 times 3, 9, 27, 9 times 2, 27, times 3, 81. 81 all over 4 minus 2 pi, then root 5 raised to power 4 can be written as 5 raised to power, square root means 1 over 2, then times this 4. 2 goes here, 2 goes into 4, you have 2, so that will be 5 raised to the power of 2, which is 25. So that means that if you simplify the numerator here, you have 25 all over 4. So 2 pi, I can factor out 2 pi into, here I'll be left with 81 over 4 minus 25 over 4. So this is 2 pi, okay, 81 minus 25, this is cannot, so you borrow 1, add, that is 11 minus 5 is 6, 7 minus 2 is 5. So that is, the denominators are the same, so we subtract 25 minus 81 minus 25, which gives us 56 all over, pick one of the denominators, 4. So this is equals to 2 here, 2 here, 2 remainder 1, 16, 2 into 16, 8. So that is 2 pi into 28 over 2. 2 here, 1, 2 here, 14. Okay, so 2 times 14, that will be 28. Then times pi. So the volume is 28 pi cubic. So if it is volume, it is cubic units. So that becomes the final solution to this problem.